In this segment, I will demonstrate generating a PAM4 signal using a Tektronix high-speed pattern generator. I will then analyze this signal using a Tektronix high-speed sampling oscilloscope. We are using the Tektronix PPG 3202 2-channel 32 gig pattern generator for this setup. That instrument is shown right here. This pattern generator is the ideal tool for PAM4 signal generation because of its very fast rise-fall times, low intrinsic jitter baseline, and flexible multi-channel configurability. The intrinsic random jitter, or RJ, of the PPG 3202 is less than 250 femtoseconds at 32 gigabaud, and the edge rates, or rise-fall times, are 11 picoseconds. I've used a Tektronix PAM4 combiner kit to combine the MSB and LSB data streams from the PPG's 2-channel NRZ channels to create a PAM4 signal. And the combiner kit is shown right here. You can see here on the PPG touchscreen interface that both the PPG channels are running at data rates of 25.78 gigabaud with single-ended amplitudes of 500 millivolts peak to peak. That's shown here on the PPG screen. Both data rate and amplitudes can be adjusted using the PPG's touchscreen. Each PPG channel can be easily configured to use both PRBS and user-defined stored data patterns such as QPRBS 13. I have employed the skew adjust capability of the PPG that is specific to each channel to tune the relative phases of the combined PP channels and create a very clean PAM4 signal with very high signal integrity and symmetry. Now that I've created the PAM4 signal, I can now analyze the signal using the DSA 8300 sampling scope, which is shown right here. The high bandwidth, low noise, and low intrinsic jitter of the DSA 8300 make it an ideal tool for characterizing PAM4 signals. Here in this setup, we are using an 82 AO4B phase reference module, which enables sub 100 femtosecond jitter measurement baseline. 80E10 remote sampling heads, which have 50 gig of bandwidth, allows measurements directly adjacent to the device under test. The output of the PSPL 5380 PAM4 combiner is connected to the scope sampling head. You can see that taking place right here. And the DSA 8300 is displaying the PAM4 signal on the screen. You can see the signal is very symmetrical with very fast rise-fall times, low intrinsic jitter, and high signal integrity. Now I will intentionally add jitter impairments real-time to the PAM4 signal using the pattern generator's jitter insertion capability. I can add random jitter, sinusoidal jitter, and/or bounded uncorrelated jitter, or budge, to both MSB and LSB inputs to create impairments for the PAM4 jitter compliance testing. So first, I will add random jitter to both MSB and LSB outputs. I've got jitter impairments added in the form of random jitter to the screen. You can see the random Gaussian component as measured by the DSA 8300. So now I will turn off the random jitter components. And I will enable the sinusoidal jitter components. So now you can see the deterministic periodic jitter added by the sine jitter impairments. Now I will demonstrate the use of Tektronix's new software analysis tool specifically designed for the analysis of PAM4 signals, the PAM4 JARB GUI. This software builds on Tektronix's expertise in analyzing NRZ signals and deconvolving total jitter into its random and deterministic jitter subcomponents, as well as measuring new industry metrics for PAM4 signals. So I will press the jitter analyze signal here on the DSA 8300, and the JRB program will automatically scan through the entire PAM4 signal to perform its analysis. You can see the JARB analysis screen has 4 major subsections. First, data and signal rate. Second, voltage level measurements on each of the PAM4 signal levels. Third, eye diagram measurements on each of the 3 PAM4 eye diagrams, including jitter decomposition and eye height and eye width. And finally, fourth, PAM4 measurements taken holistically on the entire PAM4 signal to measure such metrics as overall linearity, level thickness, and composite eye width of the PAM4 signal. Here I've demonstrated that the TEK pattern generator can be paired with the Tektronix sampling scope to create and analyze high-speed PAM4 signals. Tektronix also offers a 70 gig ATI real-time scope, which can be similarly used to analyze high-speed PAM4 signals if real-time scope analysis is preferred.